Hey everyone, and welcome to a deep dive into a question that honestly has just about everyone talking. Are we ready for AI to take the wheel?
Hmm.
But I'm not talking about just any AI. We're talking about visual language models, or VLMs for short.
Yeah, those are pretty popular right now.
They are, and these are like the brainiacs, the super smart kids of the AI world, right?
Mm-hmm.
They can understand both what they see and what they read.
Really fascinating stuff.
It's like having an AI that can watch a video of traffic.
Right.
Like rush hour traffic,
Yeah.
and then answer all these really complex questions about it. Like,
Yeah.
is that car going to change lanes?
Right.
What's the speed limit? What are the pedestrians doing? It's incredible.
There really is.
And you shared a research paper with us that just dives right into this whole hot topic.
Yeah.
And it asks this really provocative question.
Yeah.
Are VLMs ready for autonomous driving?
And that question, it leads to some really, really interesting considerations. Because we're basically asking, can we trust an AI to make life or death decisions based on what it sees on the road?
Exactly.
It's a big question.
It is a huge question. So how do these researchers even begin to answer such a complex question?
Well, they created this benchmark. It's called Drive Bench. And essentially what it does is it puts these VLMs through a series of tests to see how well they can handle these four crucial driving tasks:
Okay,
perception, prediction planning, and behavior.
got it.
But here's where things get really interesting.
Okay, I'm listening.
They don't just test these VLMs in perfect conditions, like, a sunny day with no traffic.
Right.
They throw in all sorts of curveballs, all these visual challenges.
Okay, I'm intrigued. Give me the juicy details. What kind of curveballs are we talking about?
Oh, we're talking fog, snow camera glitches, even situations where the image is completely blacked out.
Oh, wow.
Yeah, 15 different visual challenges in total.
Really pushing them to their limits.
Designed to push them to their limits, yeah.
Wow. Talk about trial by fire.
Mm-hmm.
So how did the VLMs handle this pressure? Did they crack under these less than ideal conditions?
Well, the results are pretty surprising.
Okay.
You'd think these visual challenges would just completely throw them off, but in many cases, they perform just as well as they do with crystal clear images.
Hold on. Are you telling me that an AI can navigate like a sudden blackout as well as it can navigate like a sunny day?
It seems that way.
That's mind-blowing. Can you imagine a human driver trying to do that?
Yeah,
It'd be terrifying.
right.
So how are these VLMs pulling this off?
Well, there are a couple of possible explanations, and some of them point to some potential loopholes in how we train these AI drivers.
Okay.
One issue is something called dataset bias. Many of the datasets that are used to train VLMs for driving are heavily skewed towards these common scenarios, like driving straight ahead on a clear road.
Right.
So this can lead to the model essentially guessing the right answer based on statistical probability rather than truly understanding what it's seeing.
So it's like they've aced the written exam, but haven't actually gotten behind the wheel for the real driving test.
Yeah, that's a great analogy. They might know all the rules of the road, but they haven't experienced those real-world complexities.
Right.
And there's another layer to this:
Okay.
the power of general knowledge. Remember, VLMs are trained on massive amounts of text data.
Right.
So they've soaked up this incredible amount of general knowledge about the world.
Yeah.
They might be using this knowledge to answer questions correctly, even when they're missing crucial visual information.
So it's almost like they're filling in the blanks with their book smarts instead of relying on their visual perception.
Exactly.
Fascinating, but also a little concerning, right?
Absolutely. We want them to be making decisions based on what they're actually seeing, not just what they've read in a textbook.
Yeah.
And this leads to an intriguing example that's highlighted in the research paper, the case of the turning car.
Okay.
Imagine a scenario where the VLM needs to determine which way a car is turning.
Okay.
Now, the researchers, they tested this with a completely blacked out image.
Wait a minute. How can an AI possibly figure out the direction of a car if it can't even see the car? That doesn't seem possible.
And yet the VLM got it right.
What?
It's likely relying on that general knowledge we were just talking about, for instance. It knows that cars typically go straight unless there's a clear reason to turn.
Okay.
So it might be making a statistically educated guess rather than actually seeing the turn.
That's both impressive and unsettling, isn't it?
Yeah.
It shows how intelligent these VLMs are, but it also raises some red flags about the reliability, especially when we consider, the real world implications of this.
Exactly. It's all about making sure they're getting the right answer for the right reasons.
Yeah.
And this brings us to another crucial topic: hallucination.
Okay.
Imagine an AI seeing things that aren't actually there.
Whoa, well, that sounds like something straight out of a sci-fi movie. Is that actually a thing? AI seeing ghosts in the machine?
It might sound like science fiction, but it's a real phenomenon that the researchers observed. Essentially, these VLMs can sometimes generate outputs that aren't rooted in the input data. For instance, they might report seeing a pedestrian crossing the street when the image clearly shows an empty road.
Okay, now that's genuinely creepy and more than a little concerning
Mm-hmm.
in the context of autonomous driving.
Mm.
That could have disastrous consequences.
Precisely. Imagine a self-driving car making a sudden swerve based on a hallucinated pedestrian. That's why understanding and mitigating this phenomenon is absolutely crucial for the safe development of autonomous driving technology.
Yeah, definitely scary stuff.
Mm-hmm.
So we're talking about AI potentially hallucinating pedestrians. Making driving decisions based on phantom images.
Right.
That's a pretty sobering thought. It makes you really question how we can even begin to measure, the effectiveness of these VLMs when it comes to something as critical as driving. It can't just be about whether they get from point A to point B, right?
You're absolutely right. Simply focusing on, whether the VLM gets the right answer, like correctly predicting a turn or stopping at a red light, isn't enough.
Yeah.
We need to go deeper. We need to understand the reasoning behind those decisions. We need to make sure that AI is making the right choice for the right reasons, not just getting lucky.
So how do we even start to measure something like that? What kind of tools can we use to, peek inside the AI's brain and see what's really going on?
That's a great question. And it's something that the researchers really grapple with in this paper. They explored a few existing metrics, starting with some traditional language metrics like BLU and Rouge. These are commonly used to evaluate things like machine translation,
Right.
but they fall short when it comes to the complexity of driving.
Yeah.
They're too focused on the surface level similarities between the AI's output and the expected response.
So even if the VLM spits out a response that sounds grammatically correct and seems like something a human driver might say,
Right.
it doesn't necessarily mean the VLM is thinking like a human driver or making decisions based on a true understanding of the situation.
Exactly. It's like judging a driver's skill based solely on their ability to recite the traffic laws.
Hmm.
They might know the rules by heart, but still make terrible decisions on the road.
Okay, so traditional language metrics are out. What about something more advanced? Didn't you mention something called GPT scores?
Yes, GPT scores are generated by more sophisticated language models, and they're better at capturing the nuances of language. However, even those aren't quite sophisticated enough for the intricacies of driving.
Hmm.
They don't fully account for, that split-second decision-making, the constant risk assessment,
Yeah.
the ability to adapt to unpredictable situations,
Right.
all of which are essential for safe driving.
It sounds like we need a whole new way of thinking about how we evaluate AI in the context of something as dynamic and complex as driving.
Yeah.
We need metrics that can capture not just what the AI says, but how it thinks and how those thought processes translate into real-world actions.
That's the crux of the issue. We need metrics that consider things like risk assessment.
Okay.
How well does the VLM anticipate potential hazards? We need to assess their responsiveness to sudden changes. How does the VLM react to a pedestrian suddenly stepping into the road?
Right.
Or a car swerving into its lane. And perhaps most importantly, we need to consider ethical decision-making.
Yeah.
How does the VLM handle situations where there might not be a right answer, where it has to choose between multiple less than ideal outcomes?
That's a really profound point. We're not just talking about building AI that can drive. We're talking about building AI that can drive ethically,
Exactly.
that can make decisions that are aligned with human values in situations that even human drivers find challenging.
Absolutely. And that's a tall order, which is why this research is so important. It's not just about highlighting the limitations of current VLMs.
Right.
It's about pushing the entire field to think more critically about how we design, train, and evaluate AI for real-world applications where human safety is paramount.
So let's bring this back to our listener for a moment.
Okay.
We've talked about data set bias, the power of general knowledge, the spookiness of AI hallucination, and the need for better ways to measure AI driving skills. What are the key takeaways you want our listener to walk away with?
First and foremost, I think it's important to acknowledge that VLMs hold incredible potential for autonomous driving. They're capable of some pretty remarkable feats of visual and linguistic understanding.
Yeah.
They can learn from massive data sets, make complex decisions, and even adapt to new situations. However, we can't let that potential blind us to the very real challenges that still need to be addressed.
So it's like we're standing on the edge of a new frontier, full of excitement and possibility, but also with a healthy dose of caution.
Exactly. We need to temper our enthusiasm with a critical eye. We need to remember that these AI systems are still under development.
Right.
They're learning, they're evolving, and they're bound to make mistakes.
And those mistakes could have real-world consequences, especially when we're talking about something as potentially dangerous as driving.
Which brings us back to that crucial point about data sets and evaluation methods. The data sets we use to train these VLMs need to be more robust, more diverse, and more representative of the messy, unpredictable reality of driving. And the metrics we use to evaluate them need to go beyond simply measuring accuracy. We need to be able to assess their reasoning, their adaptability, and their ethical decision-making capabilities.
It sounds like we need a whole new toolkit for the AI driving instructor, a toolkit that can not only teach these AI drivers the rules of the road, but also instill in them the wisdom, the intuition, and the ethical compass of a truly skilled human driver.
That's a great way to put it. It's not just about building machines that can drive. It's about building machines that can drive well, that can drive safely, and that can drive responsibly. And that's a challenge that will require ongoing innovation, collaboration, and a commitment to putting human safety at the forefront of AI development.
You know, it's interesting. We often hear about all the amazing things AI can do, but we don't always talk about the importance of teaching AI how to think responsibly,
Right.
especially when we're entrusting it with tasks that have, real-world consequences like driving.
That's a really important point. It's not enough to simply train an AI to follow a set of rules or achieve a specific outcome. We need to ensure that the AI is making decisions based on a sound understanding of the situation, and that its reasoning aligns with, human values and ethical principles.
So how do we go about building that ethical framework for AI drivers? How do we ensure that they're not just following the letter of the law, but also the spirit of safe and responsible driving?
Well, it starts with the data we use to train these AI systems you mentioned earlier, the need for more robust and diverse data sets. Can you elaborate on what that might look like in practice? What kind of data would we need to feed these VLMs to make them more well-rounded drivers?
That's a great question. I think it goes beyond just adding more examples of different road conditions or traffic scenarios. It's about exposing these VLMs to the full spectrum of human driving behavior, the good, the bad, and the ugly, so to speak.
I like that, the good, the bad, and the ugly. So what would that look like? Give me an example.
For example, think about all the unwritten rules of the road that human drivers learn through experience.
Yeah.
Things like yielding to pedestrians, even if they don't have the right of way, or knowing when to slow down and let another car merge, even if it's not technically their turn. These are subtle but crucial aspects of driving that aren't always explicitly codified in traffic laws.
Right, it's like that unspoken code of courtesy and common sense that helps keep traffic flowing smoothly and prevents accidents. How do we teach an AI to understand those subtle cues and navigate those gray areas of decision-making?
That's where things get really tricky. We need to find ways to translate those nuanced aspects of human driving into data that an AI can learn from. It might involve creating data sets that include examples of both good and bad driving decisions, along with explanations of why those decisions were deemed appropriate or inappropriate in the given context.
It's almost like we need to create a digital driver's ed program for these VLMs,
Yeah.
complete with virtual driving instructors who can provide feedback and guidance in real time.
Exactly. And those virtual instructors might not even be human. They could be other AI systems that have been trained on massive amounts of human driving data and can offer insights into the nuances of human decision-making behind the wheel.
Now, that's a fascinating idea. It's like creating a whole ecosystem of AI learners and AI mentors all working together to improve the safety and reliability of autonomous driving technology.
And within that ecosystem, we need to develop more sophisticated ways to assess the progress of these AI drivers. Remember all those limitations we talked about earlier with existing evaluation metrics.
Yes, the limitations of BLEU scores, RO scores, even the more advanced GPT scores, they're just not cutting it when it comes to truly evaluating the decision-making processes of AI drivers.
Exactly. We need metrics that can measure not just the outcome of a driving scenario, but the thought process that led to that outcome. Did the AI make the right decision for the right reasons? Did it consider all the relevant factors, including the safety of other drivers and pedestrians? Did it act in a way that aligns with human values and ethical principles?
It's like grading a student's essay, not just on whether they got the right answer, but on the quality of their reasoning, the depth of their analysis, and the clarity of their expression.
And just like with essays, there might not always be a single right answer. There might be multiple valid approaches to a given driving scenario, each with its own set of trade-offs and considerations.
That's a really important point. We need to move away from the idea of a binary pass-fail system for evaluating AI drivers and embrace the complexity and nuance of real-world decision-making.
So what does that look like in practice? What are some concrete examples of metrics that could capture these more nuanced aspects of AI driving?
Well, we could develop metrics that measure things like the AI's ability to anticipate potential hazards, its responsiveness to sudden changes in the environment, its adherence to traffic laws and regulations, and its consideration for the safety and well-being of others.
We could also evaluate its ability to explain its decisions. Can the AI articulate the reasoning behind its actions in a way that makes sense to a human observer?
That's a crucial point. Transparency and explainability are essential for building trust in AI systems, especially those that are making decisions that could impact human safety.
It's like that old saying, trust but verify.
Hmm.
We need to be able to not only trust that these AI drivers are making sound decisions, but also verify those decisions through rigorous testing and evaluation.
And that testing and evaluation should go beyond just simulated environments.
Yeah.
We need to see how these AI systems perform in the real world with all its unpredictable complexities and challenges.
So it's not just about building better AI drivers, it's about building a better ecosystem for testing and evaluating those AI drivers.
Right.
We need a system that can rigorously assess their capabilities, identify their limitations, and ensure they're ready for the responsibility of navigating our roads.
And it's a journey that requires collaboration between researchers, engineers, policymakers, and the public. We all have a stake in ensuring that AI is developed and deployed in a way that benefits society and enhances our lives.
Absolutely. It's a conversation that needs to continue, and it's a responsibility we all share as we wrap up this deep dive into the world of VLMs and autonomous driving. What's the one key takeaway you'd want our listener to ponder?
I think the most important thing to remember is that the future of AI, especially in a field as impactful as autonomous driving, is not predetermined. It's a future that we are actively shaping through the choices we make, the questions we ask, and the standards we set.
So it's not just about whether AI is ready for us, it's about whether we are ready for AI.
Precisely, and that readiness involves not just embracing the potential of this technology, but also recognizing its limitations, mitigating its risks, and ensuring its development aligns with our values and aspirations for a safer, more equitable, and more sustainable future.
Thanks for joining us on this deep dive. Until next time, keep exploring, keep learning, and keep asking those tough questions.